Okay, so this is a discussion on how to solve a side-side-side triangle. And if you have this handout, that's the one I'm talking about, and it goes on like this. Okay, I emailed that to you guys. This is a verbal discussion of that. By understanding side-side-side, you also learn angle-side-angle and side-angle-side. Okay, those are kind of going to come along for free. Please note that if you know two angles, you know the third angle. So there's no real such thing as angle, side, angle. It's like angle, angle, angle with this one side. Okay? All right. Right. So if we have, for example, this was the example that was given in the worksheet. If I started you off like this, let's say this is your exam question and it says solve the triangle. What this means is you want to find angles A, B, and C. And in that case, you would label the sides A, B, and C, like that. Okay? And so what I'm suggesting, first of all, is to not deal with this obtuse angle until, let that be the last thing you deal with. That's my rule of thumb. If you can avoid it, don't try to look for that obtuse angle, because if you do, you're going to end up having to deal with reference angles, which it's better to avoid, but I will show you how to deal with that if you have to. Okay, so the law of cosines, and you could scramble these letters, is a squared plus b squared is equal to c squared plus 2ab cosine little c. And it's written differently in some textbooks, but this is the way I prefer to think of it. And so I'm going to just go ahead and take a, which is 165, and square it, and b, which is 368. Sorry. 368 and square it is equal to 216 square it plus 2 times 165 times 368 times cosine of little c. All right, and you can fast forward through the video if at any point you get bored. That goes without saying. Okay. So if you're still here, you're watching me write these numbers. Okay, there you go. So all I did is 2 times 165 times 368 is 121440, and those squares were written down. Okay, so what's the next step? Now I'm going to subtract, well, I'm going to add these two together, and I'm going to get 162649 is still this mess plus this mess. In gory detail. It's not necessary to write out every single step, but it makes it easier for me if you write every step out, because then if you mess something up, I can see exactly where you messed up and you can get more partial credit than you would otherwise. But that's the theory. It doesn't always work, but it sometimes works. Okay, so you get all the way down to here. Now, I'm going to actually look up a trig table for you. Okay, for whatever reason, this trig table doesn't include all the angles that we might need, but that's fine. I'm not really sure why they did that. We're looking for an angle, we're looking for C, such that cosine of C is 0.95515. So we look for a cosine, so we're looking at this middle column, and we want it to be 0.955 or something in that vicinity. So I'm looking here, I have to look in the middle column. 0.95, then this is fairly close. This is 17 degrees. So I'm going to also do it on a calculator. We don't actually know how to do it on the calculator. Well, let me find another calculator. Well, okay, you know what? It turns out that this works great if you just go to Google and start typing in. It will give it to you in radians, but If you want degrees, you can say in degrees, and it just goes ahead and shows you. And so the answer is going to be 17.2, and so little c is equal to 17.2 degrees. Okay, and on your calculator, you usually hit a shift or a second key, and then cosine, and then 0.95515, and then equals, and then you'll get that value. Okay, so this is now 17.2 degrees. All right. So the great thing about side triangle is then I've used the law of cosines. I can now show you how to use the law of sines because I now have essentially a side angle side problem, except that I have a free side. I get a free side. So what can I do? I'm going to pause this for a second. So I erased all my results, and then I'm going to show you the law of sines. All right. And so what this says is the sine of 17.2 degrees divided by 216. So it's the sine of this divided by that value is equal to the sine of this divided by that value, which is equal to the sine of that divided by that value. That's the way you should think of it. And it doesn't matter which things go in the numerator and which things go in the denominator, so long as you're consistent. Like I said in class, that it's so last century to care about putting the sine and cosines or square roots or anything like that in the numerator of a fraction. That's just, we don't need to worry about that anymore, but we just have the habit of doing it because we're taught to do it that way. But the need is no longer there. So I don't care if you flip the whole thing upside down. Just be consistent. Okay. Okay, so that's what that's saying. And then we're going to break this into two separate problems. We're going to say sine of 17.2 degrees over 216, which happens to equal, if you just plug that into your calculator, you get 0.0013690. And see why I think this is stupid? Because these two zeros are not significant digits, and a lot of students will think they are. But this is where your information is, in an information theory sense, that these zeros are meaningless. They don't help you with the problem. Okay, so then I'm going to say, well, 0.001369, I don't need to write that zero, is sine of b over 368. And I'm going to abandon that. I'm going to abandon that, and I'll come back to it, because it's going to be a mess, and I'll tell you why. But I'm going to look at the other problem. I'm going to multiply both sides by 165, and then I'm going to get 0.22589 is equal to the sine of A. And then I'm going to look that up on my trig table again. This guy, right? I'm going to look up in the first column, can I find a 0.225 or something nearby? 0.225 is about 13 degrees. And again, I can go to Google, and this time I'm looking for arcsine of 0.22589, and it tells me it's 13.1 degree. I'm just going to go like that. A is equal to 13.1 degrees. Okay, now here's what the truth is. This A is 13.1 degrees. So now I'm just going to go back to Google or whatever calculator I want. And I'm going to say 180 degrees in a triangle minus the 17.2 we calculated minus 13.1. And that's going to tell us 149.7. And so this guy has to be 149.7. We got it for free. And let's see if this makes sense, right? If I have 149 degrees, what happens if I say sine of 149 degrees divided by 368 is going to be that number we've been hauling around. Well, it's not exactly, but it's really, really close. 149.7 we got. So let's do that. There we go. That's closer. Okay, so that's true. However, what if I ask the other question, an angle whose sine is 0.5038 in degrees is 30.25. Well, what's the problem here? I thought we just said that we had an angle whose sine was 0.5038 and it was the right answer. But the problem is, what is the sine of 30.3 degrees is 0.5045. But what is the sine of 149.7? It's the same thing. So the problem is when you have an obtuse angle, you gotta account for that. And so that's why you have this mess. And so when you look up the reference angle, you're going to get 30.3. So you actually have to say it's going to be 180 minus arc sine, and I'm writing it with a capital A on purpose, 180 minus the angle whose sine is blah, 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 whatever it is. What was blah, blah, blah? It was whatever this value is, 0.001369 times this value. You know, I never gave you this value. I'm sorry. 5038 is what that was. Okay? So that's what blah, blah, blah is. Let's put the number in here, 0.5038. Okay? So that's what's happening. Because it's an obtuse angle, that's what you got to do. What a pain. So let's just not do that. Let's just not go through that whole painful process. And we're just going to say nope. And then we're just going to say, look, we know this angle and it's easy, and that angle is easy, so we're just going to calculate this by 180 minus those other two angles. Okay? I think that covers everything I need you to know. Yeah, the only other thing you need to keep track of is that sometimes you need to solve for the length. So for example, let's say you got all these sides to work out, all right? And you do have this pair, but maybe you didn't know B was 368. Okay, maybe we need to find B again. Okay, so we don't know what B is. Suddenly we forgot. We're still going to calculate this value right there. And we're still going to do most of the same stuff that we're doing. It's just that the unknown is going to end up in a different place. So we're going to still say 0.001369. And now we're going to say sine of 149.7 over Q, which we want to know. Q is going to be sine of 149.7 divided by 0.001369, and then we could do that. Sine of, wait, we already have this sitting here. Sine of this value divided by 0.001369, and it says 368.5. So we're off by a little tiny bit. 368. And you know why that is, because we started with exact integers and then we got these angles. These angles aren't perfect. So then when we try to reverse engineer what length came from that, then that's not going to be perfect. So anyway, yep, then if you understand this, then you understand everything you need to know for my final. And hope you're having a good time studying. See you soon.